Last minute revision for chemical kinetics. The rate of the reaction, that is change in concentration of either reactant or product with respect to time, is the rate of the reaction. Let us consider this reaction: nitrogen plus hydrogen gives ammonia, right? That is, we can understand that the formation of product will have a positive sign here, and the formation of, and the disappearance of reactant will have a negative sign here. Because here the product forms on, that is why we are making the plus here. Here the reactant decreases, that is why we are making the negative sign here. And the coefficient should be written as fraction here, 1 by something, 1 by, here it has been written as 1 by 3, and here it has been written as 1 by 2, and here in front of nitrogen is nothing there. So right, this is a rate equation, right? Rate of the reaction shall be written by like this, and the unit of rate is mole per liter per time, or mole per liter per second. Instead of time we can write second too. Right, the rate law. What is rate law? It's nothing but the expression of rate of reaction in terms of concentration. The same thing, the rate of reaction, if you are writing in terms of concentration, that is in the square bracket, that is called the rate law, right? So for this reaction A plus B gives product, the rate is equal to concentration of the reactants here raised to the power of its coefficient. Here, if this is a coefficient, means there should be A here instead of X, there should be A here. And here instead of Y, there should be B there. Right? This is a rate law. And rate constant is nothing but rate of reaction when the concentration is taken as a unity. That rate constant, that is equal to rate, that rate is equal to the constant rate. Unit of rate constant, that is equal to mole per liter into per time. For gaseous reaction, the unit of mole constant may be atmospheric to the power of 1 minus n into per time. N is the order of reaction. Order of reaction is nothing but the sum of power of concentration of the rate law expression. Here this is the rate law now. Right. So this is the order of the reaction. X plus y is the order of the reaction here. That has been given itself. X plus y is the order of the reaction. It may be 0, positive or negative or fraction. So it is an experimental quantity. That is the order of the reaction. Mechanism of reaction. Mechanism of the reaction means a reaction may take place on a single step or several steps. Right. If it is takes place in a several step, the first step is called as the elementary reaction. The chemical reaction completed in single step and have exponent and rate law expression is equal to the stoichiometric coefficient. Zero order reaction cannot be an elementary reaction, right? And then complex reaction, the overall reaction is controlled by the slower. So this we know that the rate determining step, the RDS of a reaction is nothing but the slowest reaction. Elementary reaction is nothing but the reaction, the first step in which the reaction starts on, right? That is the elementary reaction. And difference between order and molecularity. Order, we can see the sum of the exponent powers of the concentration terms. That is the order. And molecularity is nothing but the number of atoms, ions, or molecules that must collide with one another to the reaction to take place. That is the molecularity of the reaction. Rate law can be determined experimentally, and the molecularity cannot be determined. It's a theoretical concept. It can be determined only from the slowest step. Order of a reaction may be 0 or negative, but rate will not be 0 or negative. Order of a reaction may be fraction, but the molecularity of the reaction may not be fraction. The molecularity of the reaction may not be never 0 or negative.